Hello everyone, this is Vishnu and my topic for concept video for subject COA is on introduction to parallel computing. So let's get started. So what exactly is parallel computing? So it's a type of computation in which many calculations or processes are being carried out simultaneously or parallelly. So large problems can often be divided into smaller ones or been segregated or into or been convert uh, or been divided into smaller fragments and ascended, and the data is been provided to the processor by different threads, so with which we can achieve parallel computing. Well, these threads will send data to the cores, and these cores will take care of the computations or the calculations of the data that needs to be performed. So this is how we can achieve parallel computing. And coming to the advantages of this parallel computing is that it reduces time and it does increase efficiency. So, and it can be achieved by multi-core processors only. And this parallel computing can also now be implemented, not now, but it's been implemented in GPUs, which are nothing but the graphical processing units as well. And FPGAs can also achieve it since they are field programmable gate arrays. So parallel computing can also be achieved in them, and GPUs as mentioned, and processors which consists of more uh, two or more than two cores. So with the help of that, we can achieve parallel computing. Moving on. So sequential computing, which is completely opposite to parallel computing, where sequential computing uh, will only execute a program one after the another or one at a time. So it can so this kind of computation can be achieved by single and as well as multi-core process as well, where we can only specify a single code to do the job. So the sequential computing can be done by single and multi-core process as well. So coming to classes of parallel computing, so there's a multi-core computing where a multiple core or multiple processors are embedded into a single chip that include a single chip, which are commonly known as cores. So if we open the heat shield of a chip or a processor, we can have a look at the black uh, rectangles, which are nothing but the CPUs, or we can also call them as cores. So, and coming these processors differs from a superscalar processors, which includes multiple execution units and can issue multiple instructions per clock cycle. So one instruction stream or the thread. In contrast, a multi-core processor can issue multiple instructions per clock cycle with multiple instruction streams. So moving on, cluster computing. So cluster computing is kind of a computing where the computers are work together closely, so that in some respect they can be regarded as a single computer. So cluster is nothing but two or more computers which are being interfaced to each other, and the hardware which is there and the two or more computers are being utilized. It's not like only one CPU and that CPU is doing all the job. It's like two or more different, completely different computers, PCs or laptops which have been interfaced, together with the help of TCP or IP internet, TCP or IP internet, Ethernet local area network, Ethernet connection, which is nothing but one of the fastest way of transferring the data from one place to other place. So the most common type of cluster is the Beowulf, Beowulf cluster, where where the top 500 supercomputers are clusters, where these supercomputers are been clustered together, and they are sent, or they are ordered to perform a particular set of tasks. Uh, so let's say like calculating the distance between us and the other planets, or any and or any other intensive AI algorithm, or a complex algorithm. So in those cases, we use cluster computing for processing the data. So distributed computing. A distributed computer is also known as the distributed memory microprocessor, where it's a distributed memory computer system in which the processing elements are connected by a network. Distributed computers are highly scalable. So the terms concurrent computing, parallel computing, and distributed computing have a lot of overlap, and no clear distinction exists between them. The same system can be characterized both as parallel and distributed. The processors in a typical distributed system run concurrently in parallel. So what exactly is the slide means is that the memory has been distributed throughout the uh, systems, and these are interfaced by a network. Concurrent computing, parallel computing, distributed computing have a lot of common, or a lot of similarities in their functionality, and there's no clear distinction that exists between them. So these same systems have been maybe characterized both as parallel and distributed. So since there's no clear definition for them, it's been considered as both parallel and distributed. The processor is a typically distributed system which can run concurrently in parallel. Moving on, general purpose computing on graphics processing, which is nothing but the GPUs, graphical processing units, are co-processors that have been heavily optimized for computing computer graphics processing. So computer graphics processing is a field dominated by data parallel operations, particularly linear algebra matrix operations. That's why all kinds of AI algorithms, or the machine learning or deep learning algorithms, are being trained, or these algorithms are trained with data only with the help of these GPUs, since they are very since these GPUs are very good at performing matrix operations. So um, we use GPUs for that. Moving on, we got types of parallelisms, where we got bit level parallelism, which is nothing but which is a form of parallel computing which is based on increasing processor size. Well, it reduces the number of instructions that the system must execute in order to perform a single task on large sized data. Moving on, instruction level parallelism. A processor can only address less than one instruction for each clock cycle phrase. These instructions can be reordered and grouped, which are later on executed concurrently without affecting the results of the program. This is called as the instruction level parallelism, where this slide states that the parallelism is based on the instructions which are sent to the processor. So moving on, task parallelism. So task parallelism employs the decomposition of a task into subtasks and then allocating each of the subtasks for execution. So the processors perform the execution of subtasks concurrently. So where the one program is being segregated into fewer parts, and the fewer blocks of the hardware will perform uh, one kind of operation at a time. So, which is nothing but the task parallelism, where the task is being divided into subtasks and assigned to different threads and cores of the um, processor. So, moving on, super word level parallelism. Super word level parallelism is a vectorization technique where vectorization is nothing but the array formations, where a large data is being stored in the form of an array. Vectorization, so it's a kind of a vectorization technique which is based on loop enrolling, unenrolling, and basic block vectorization. It is distinct from loop vectorization algorithms in that it can exploit parallelism of inline code, such as manipulating coordinates, color channels, or in loops unenrolled by hand. So that's it, everyone. Thank you.